This question is looking at a t-test. So we can see there the keyword is the t-test and it's at a 5% significance level. And we're comparing the different weights between the chinchilla rabbit and the sable rabbit. Okay, so a t-test will, when you've got two sets of data from two different groups like here, it compares how similar they are and it says, is it likely that the mean or the average of both groups are the same? And yes, we know that in reality, they're going to be slightly different numbers, even if the means are the same. It's looking at how likely is it that our data is just a bit not quite there, but it would be from the same groups, or is it really fluky and therefore we're not convinced that the original means were the same at all. So for the first part, we're writing down the null and the alternative hypothesis. So the null hypothesis, whenever you do a t-test, is always that the mean of each group are the same. So we should really label here. I'm going to use the C and the S, okay? So the null hypothesis is that the mean of the chinchilla is equal to the mean of the sable. And then the alternative hypothesis, which you can label as either 1 or A, so either of those options would be fine, is that the mean of the chinchilla and the mean of the sable are not the same. And we need to decide, is one bigger than the other, or are they just not equal? So in the question, it says that the aim was to find out whether the chinchilla are heavier than the sable. So that means that our alternative is that the chinchilla are heavier than the sable. Okay, so C is bigger than S. And then for the second part, it asks us to find the p-value for the test. So this is where we're going to be using our GDC to find in the data for the two sets. Okay, so I've got the chinchilla and the sable, and we can then do menu, statistics, stats tests, and t-test. Okay, so it's a t-test, and what we have is two sample. Okay, we've got two different samples, one for the chinchilla and one for the sable, so it's a two sample t-test, and that's the only type of t-test we do on this course. Okay, so we always know that it's going to be that. So the first list is the chinchilla, and the second list is the sable. So I'm just doing it in order of how it was asked in the question. And then we need to correct the alternate hypothesis. So it automatically will put it in as this one. We want the top option there. We want 1 to be bigger than 2, because 1 is C and 2 is S, and we want C to be bigger than S. And then we always need to change the pooled. So we should have pooled yes. Okay, if you don't tick that, you'll get it wrong. So pooled is yes, and then that gives me my t-test and my p-value. So the question's asking for the p-value. So the p-value there is going to be 0.04087, or to three significant figures, 0.0408. Okay, and then part C is to write down a conclusion of the test. So we need to decide, are we taking the null or are we taking the alternate hypothesis? So the easiest way to see that is just to draw a quick sketch. So we know that a t-test comes from a normal distribution of data, and we're looking to see if the two are the same or not. So the p-value was 0.0408, or I could think of that as 4.08%. And my significance level in the test was 5%. That's written directly under my table, so 5% significance level. So my cutoff point there is 5%, and that's the point that decides, is it the alternate or is it the null? And my value we just wrote was 4.08, so my area is less, it's only 4.08%, and therefore we can see we're in the alternate hypothesis section. So we're going to reject the null hypothesis, reject H0, and we accept the alternate H1 or HA.